Hi everybody, logs part 2 here. Now, this is an extension of what I was talking about for that problem number 3 in the first video. Log expressions, whether they're common log or log of any base or natural log, have properties that allow you to rewrite them. So we can rewrite the log of a times b as the log of a plus the log of b. We can rewrite the log of a quotient as the difference of two logs. And then the third property, the one I already talked about, the log of a to the b power is equal to b times the log of a. A couple other facts to remember is that if we take the natural log of 1, we get 0, and the natural log of e is equal to 1. You may need to go back to your summer packet and look over the things about natural log and e as we're working through this unit. All right, so having the log properties as tools to allow us to rewrite things lets us avoid potentially product rule, quotient rule, chain rule scenarios. And I'm going to show you 2 examples and leave the other ones for you to do. So let's take a look at this number 14. I'm going to do a little screen capture toolbar here and move this to another screen because I need my big old bunch of space for writing. I write big. Okay. So one way to take this derivative would be just to look at it and go, okay, I've got the natural log of the root of this expression. So my derivative for a natural log, if I have the natural log of something, okay, or u, the derivative is 1 over that u times the derivative of that u. Now, the u happens to be a root of an expression. So when I take the derivative of the root of that expression, I'm going to have 1/2 x squared plus 2x minus 3 to the negative 1/2 times another 2x plus 2. And I will be putting all of that, I'm going to actually get rid of my line here because we went over the line. Okay. I would have to take all of that and put it together in a more simplified form, probably if we were looking at a multiple choice problem. If this was a multiple choice question, the answer would not look like this. So I would have 1 over the root, and then I would have the half, and then I would have, well, this to the negative 1/2 is 1 over another root of that, and then this, but it's would be over 1. So I would end up with 2x plus 2 over 2, from this 2, times, and if I take this root times this root, I get what's inside the root. Or I could write that as x plus 1. If I take out a 2, x squared plus 2x minus 3 plus 3 minus 1. Okay. And that would be my simplified derivative. Definitely a lot going on here. 1 over the root times the derivative of the root expression, and taking the derivative of a root expression includes a little chain rule. Now, let me show you something. If I take the exact same problem and I stop for a minute and look at it as, oops, not a 1/3, a 1/2, excuse me. Whoa, I'm just writing with an eraser. Okay, how about plus 2x minus 3 to the 1/2. Right. If I rewrite that using a log property, and I make that 1/2 natural log x squared plus 2x minus 3, and then I take the derivative, the 1/2 isn't going to change. That's a constant times something I'm taking the derivative of. 1 over x squared plus 2x minus 3 times the derivative of that, which would be 2x plus 2. And then I could divide that 2, divide a 2 out of this, and I'm ending up at the exact same derivative expression with a slightly easier path. Okay. Now, you may disagree. You might be like, nope, I don't know the log properties, I don't remember them, so trying to remember that and then remembering how to take the derivative of a natural log, too much stuff to remember. Okay, then you've got to do this. And your derivative will be written out pretty quickly, but your simplification will take work. If you can remember this rewriting property, that the log of something to a power can be written as with the power times the log, then the derivative part actually becomes a little easier to do. And your simplifying becomes a little less clunky as well. It's a matter of, do you recognize that you've got that option? Okay. If you're doing a natural log derivative and it's really crazy, it might be easier to rewrite it. You may have missed that as an option. You're going to look for that. Let me get out of dual here. You're going to look for that when you have the natural log of a quotient. Okay? Because if I can rewrite this, I will eliminate my need to do a quotient rule on the derivative of that part. So I rewrite this as y equals the natural log of x squared minus the natural log of 3x minus 2. I can take the derivative of that, and it will be a lot easier. Splitting up a product. And here you've got a quotient and a root, so, and you've got a root up here, so having something under a root typically creates the scenario where you're bringing that 1/2 down to the front. Okay. So I will not be writing answers for 15 and 16 and 17 in a without rewriting the problem first. On all three of those, I'm going to rewrite the problem. Nobody can force you to rewrite the problem. You don't have to rewrite the problem in order to find these derivatives. But in most cases, you're going to have to follow a rule, like a quotient rule when you get to the second part. If you do 1 over this fraction times the derivative of this fraction, the derivative of this fraction requires product rule, requires quotient rule. If you do 1 over this set of parentheses times the derivative of the set of parentheses, the derivative of this set of parentheses requires product rule. Ooh, that's the bell. Okay. So your next challenge is to see if you can rewrite 15 and 16 and 17 using log properties, and then write the derivative of those new expressions.